Okay, so the area problem really says this. Okay, and you guys probably won't have an assignment tonight. We'll get through this just fine. Suppose we have a function f of x. And suppose that we bound that function, okay? Suppose that we bound that function from a to b. The question is, what is the area? And Newton was able to put this in calculus form for us to all understand. There were people who were able to find the area by other methods. The quickest way is to use calculus. And we're going to do exactly like what many of you guys did, and what a lot of you guys did is you drew rectangles, okay? And that's absolutely fine. I'm going to draw 2 rectangles here, okay? And I want you to see what happens. And I'm going to draw what I call left-handed rectangles. Okay. So these are rectangles that are from the left side. If I'm going to draw 2 triangles, how many regions should I divide A and B into? Just 2 regions. If I draw the left-hand triangles, I start on the left-hand side of each interval. So this interval here, we'll call this middle spot, we'll call it C. So for this interval AC, I would start over on A, and I would draw my rectangle. I would start here at A, and I would draw it up to where the function is evaluated. And then I would draw it over to C. What do you think? Is that rectangle an overestimation or an underestimation of that area? That'll be an over. I cut off a little bit at the top, but I get some extra over here, so that looks like an overestimation. Okay, for my second rectangle, I look at the interval C to B. And I go to the left side of that interval. So, say right here at C. And I draw it up to the function, then I draw it over. That looks like an underestimation. So maybe all together it would work out pretty well. But that would be what we would refer to as left-hand rectangles. We draw it on the left hand of the region. Now if I switch this, let's suppose I were to go to the right-hand side. If I go to the right-hand side, then from C to B, I would start at B, and I would draw it up here, and over to C and down. And then I would draw it from C up and over to A and down. So that would be a right hand. It's okay. Now, for this purpose of this class right now, what we're going to do is today, we'll eventually focus on left hand, and we'll focus on right hand. We also do what we call midpoint. Instead of choosing A or C to draw it up from, we choose the middle and we draw it up from there and over. If you simply average the left and the right, you get the trapezoidal sum, which is very accurate. And we'll practice all those, boys. But today, I just want to do a basic example, and today we are going to focus on just right hand. Now, I need you to set something aside today. Today, you're going to look at the answers. You're going to say, that answer is absurd. You're going to say, it's so far off, we're not even close. I could see it by our picture. Who cares? Today you just want to learn the process. You're going to learn how to do this by hand and get it exact. And each problem's going to take you like half a page or more. Okay? But it's going to be fun too. So let's do this. Find the area bounded between the curve f of x equals x squared, the x-axis, and the line x equals 4 by constructing two rectangles and 4. We're not going to do 8 or 16 today. I'm going to show you how to do those using your calculator a little bit, okay? So, we're going to do 2 rectangles and 4, and we are going to do right-hand rectangles in both scenarios. So I'm going to draw the function y equals x squared. I start here. And we're going to bound it from 0 to 4. Yes, I did. My wife is left-handed too. Yes, I did. So, we're going to take this this shape and we're going to draw right-hand rectangles. And so what I'm going to do is I'm going to start by dividing this up into 2 regions. Just 2. Okay? So if I divide this up into 2 regions, what's the... Yes, 2 is the spot where I divide it. The first rectangle that I draw from the region, I like to start, if I'm doing a right-hand side, I like to go all the way over to the right and start over there. So, boys and girls, it's going to take us a long time to get through this. 2 and 4. I start at 4. And I go all the way up. Can you tell me what is the y value of that rectangle? How high is that? 16. You squared the 4. The function is y equals x squared. So you plugged in 16 in order to get your height. Okay? So is that an overestimation or under? Right-hand rectangles are not always an overestimation, but in this case it will be. So then I go to 2 and I draw my rectangle. Okay? And what's the height of that one? 4. So, it's obviously a very poor approximation. What I need to do is I need to take the width of each rectangle. What's the width of each rectangle? So 2 times, what's the height of the small one? 4 plus 2 times 16. So we would get 40, which is a very large overestimation. Should we come up with a better one? Let's do that. Now what we're going to do is we're going to divide it into 4. And this will change your drawing a little bit, but not much. Don't worry that you don't have a different color. It's going to work out just fine. If I divide it into 4, how wide is going to be each interval? Each interval will be 1. So I need to add a 3 in here. I need to add a 1 in here. Again, I'm doing right-hand rectangles. So I start at the right-hand side. What is going to be the height of my first rectangle? 16. The next one I draw going up at 3 and over. What's going to be the height of the one from 3? 9. Then I draw one from 2 up and over. The height of that one is 4, and I draw one from 1 up and over. That is 1. So what I need to do is take the width of each one and multiply it by the height. Now, I know that the width is 1, so we could just disregard it, but I'm not going to do that because I'm trying to teach you something. The width is 1 times 16 plus 1 times 9 plus 1 times 4 plus 1 times 1. Yes. 16 plus 9 is 25, plus 4 is 29, plus 1 is 30. So you can see by dividing into 4, we got a much better approximation. Can I show you something that's happening here? Yes, we will make a billion rectangles, but we're not going to do that for a while, so I want to try to show you a shortcut here. See how you're going to have the width in each case? So we could factor that out, couldn't we? You could take 2 times parentheses 4 plus 16. Now, I'll even write that differently. 2 represents our width. You could take the width times 4 plus 16 happen to be our heights. We found our heights by plugging in the number into the function. So basically, this is the width times the sum of our heights. Now, that's really, really kind of raw notation. We'll transfer that mathematically, but that one idea that you take the widths and you multiply it by the sum of the heights, that's really, really important, okay? And so we're going to continue to try to do that over and over and over again. 8 and 16 becomes very, very tedious. Very tedious. So we're going to use our calculators for those after a while. What I want you to do is flip it over the back side, see if we can get started on one of a different shape. Yep, we'll say 30 is our approximation, and we know it's an overestimation. We're just doing this so then you guys will be able to do the infinite one. So we want to get to infinity, but you first have to practice this and know how to do this. Okay, I'm going to draw this curve, negative x squared plus 16. What does that look like? It's a parabola, it's upside down, and it crosses up at, good. So I have this shape. Because it says area bounded between this, the x-axis, which is this line, the y-axis, which is this. So it's that region bounded by those three equations. And we have, it crosses the x-axis at what spot? 4. So again, I try to create ones that would work out rather nice. And again, in this situation, what we're going to do is we're going to do right-hand triangles. So let's just go a little bit nicer here. If I divide this up into 2, what's my middle spot? 2. Okay, I'm going to go to the right-hand side. If I go to the right-hand side, I'll start at 4. What's the height of that rectangle? It's 0. Because if you plug in 4 into the function, you get 0. If I plug in 2, what's the height there? Plug it into your function. 12. So remember, we're going to write a little bit shorter hand way of figuring out exactly the areas. I don't have to put it in the width every time. I can simply write the width times the sum of the heights. So what's the width of each of these rectangles? 2 times, what's the first height? 0. The second height? 12. And so we get 24. Is that an overestimation or an underestimation? This is an underestimation. So again, just because you draw right-hand triangles does not mean that you will get one or the other. Totally depends on the shape. Now it's divided up into 4 regions. Okay, if I divide it up into 4 regions, I now need to create 1, so if you plug in 2 squared is 4, make it negative. Okay. So let's divide it up into 4 intervals now. If I draw my rectangle from 4, what's the height here? 0. Now I'm going to plug in 3. What's the height there? 7. Now I plug in 2. What's the height there? 12. Now I plug in 1. What's the height there? 15. So you can see all of my heights. So if you want to be able to find the approximated area by 4 rectangles, you'll take the width. What is the width? 1, and multiply it by the sum of the heights, which is 16 plus 15 plus 12. Well, I'm sorry, 15 plus 12 plus 7 plus 0. And what we have there is 27, so 34. So that's a better approximation. Obviously, if we plugged in 8, we would get even better. Obviously, if you went to infinity, we'd get even better. Okay, so today is just a basic, is this kind of in your head? Do you understand the process? Okay, so now tomorrow I'm going to give you some time. I want you to be able to work through some of these, and you need to go through the tedious process to really get it ingrained in there. Then we'll start working towards infinity, and after that we'll work towards the calculus. Hold on to this, though. Hold on to this because we're going to use this tomorrow.